Okay, so this is question number 4, the probability questions from the Northern Hemisphere exam. Beacon Petrol Station has 2 pumps, A and B, to inflate tyres. Each tyre is independent of each other. When pump A is set to that, the pressure that all tyres inflated will be a normal distribution of mean 320 and standard deviation of 10. Probability that a tyre inflated will be greater than 330 inflated when pump A. So probability that A is bigger than 330 should be a normal 330 to infinity, where 320 is the mean, standard deviation is 10. So on a calculator, distribution continuous, normal CDF, we're going from 330 through to infinity, 320, sorry, 10 and 320, and I get 0. So I'm going to make that 10 and that 320, and that's 0.158655, 0.1587. Okay, question is the probability that a tyre inflated to is 90%, so inflated to a pressure greater than alpha. So I've got my normal. That must be alpha here. That probability is 0.9. So I'm going to do the inverse normal with a right of 0.9 and 10 and 320. So distribution inverse normal CDF. I wish for a right, and the probability is 0.9, and that's 10, and that's 320. And that gives me 307.18. And I'm doing it correct to the nearest kilopascal. So the nearest kilopascal will be 307 as being my answer. When pump B is set to 320, its distribution is this, between 310 and 330. Determine the mean. So my mean is going to be the integral of x times b of x from 310 through to 330. So I'm going to have math 3, the integral from 310 to 330 of x times all of this. So 3 divided by 40,000 bracket x minus 310 squared times 330 minus x dx. And I get 40,000, so I get 322 is the mean. A randomly selected tyre is inflated by pump B. Find the probability this tyre will be inflated by pressure greater than the mean tyre, so probability that B is bigger than 322. Probability, okay. So let's just go into the integral from 322 to 330 of b of x dx. So if I get rid of the x and I put 322 in here, that's going to be equal to 328 on 625, and I've got to do it to 4 decimal places. Why do I ask 4 decimal places when I get an exact answer? 0.5248. Now, it won't necessarily be 0.5. That would be the median. Okay, so over the page, probability type B is less than K. So I've got my distribution. So I'm less than K. So K down to 310 of B of x dx equals 0.95. Solve for K. So I'm going to put that back down to 310. I might make that up there. Y. And that gives me an expression. I want to make that expression equal to 0.95, and I want to solve for y. And I get 328, 331, 328 or 331. Since my upper limit is 330, I'm going to take 328. So K equals 328.0477 to the nearest hectopascal. K equals 328. Question F. A motorist is likely to use either A or B to inflate their tyres. What's the probability that a motorist uses A? Probability of A given pressure is greater than 325. So it's going to be the probability of A intersect pressure greater than 325 over the probability that pressure is greater than 325. So I need for A the pressure to be greater than 325. So I need to do interactive distribution continuous normal for 325 up to infinity, where 10 and 320, so the probability is 0. Keep on getting these around the wrong way, don't I? And for B to be greater than 325, I'm going to grab this. Copy, go down here, paste, and I'm going to go from 325 to 350, sorry, 330. So I should have this as my intersection over this plus this. So at the bottom is all the ways you can have greater than 325, and that gives me 0.54, 0.5411 to 4 decimal places. Beautiful. In G, the company tells all the pumps to remove those who are defective. The probability around the pump is defective is 0.08. Probably 4 pumps are defective in a sample of 25 to, so it's going to be binomial, right, 25, 0.08. I'm looking for the probability that the effective pumps is equal to 4. Find the probability that 4 pumps are defective from a sample of 25. So I've got binomial, PDF, I've got 4, I've got 25 pumps, and the probability of being defective is 0.08, and that gives me 0.0899, 4 decimal places, and there's a 4 after the 0.899, the 0.0899 is going to be my answer. Probability of the sample of 25, p hat, so the probability that p hat is greater than 0.15. Turn that into x by timesing by 25, so probability that x is bigger than 3.75, which means probability that x is bigger than or equal to 4. So I'm now going to do binomial CDF, 4 to 25, 25, 0.08. Interactive distribution, discrete CDF. My lower is 4, my upper is 25, my n is 25, and my p is 0.08. That gives me 13509. So 1, 3, how many 4 decimal places? 5, 1. And over the page, find n. So we'll times by n, so probability that x is less than 1 is less than 0.15, so the probability that x equals 0 is less than 0.15, so I'm going to bring this into a new line. I want, actually PDF, I want to have that 0, and I don't know n, so if it was 25, it's less. What about 24? 1135, 23, 0.146, 22. It's too big. So 23 is the first value I get to, where it's less than 0.15, therefore n equals 23. And that's the end of the problem.